Hello everyone, welcome to Proof of Concept channel. As part of POC today, we are going to see one very interesting use case, that is digits classification using random forest classifier. The objective of this proof of concept is to build a machine learning model to predict digits 0 to 9. We are provided with a set of sample images. That images contains digits 0 to 9. That's a handwritten images. Our model is going to predict and tell us what image digit it is. That is the objective of this POC. The following steps involved in this process: load required libraries, import dataset, display all digits 0 to 9 using matplotlib, build a random forest classifier model, make a prediction for test data, and a summary. Before going to the further steps, let me explain about the datasets. Let's go to Google and type sklearn load digits. So this is our datasets. Let me click here and sklearn load digits. So the datasets contains 8 cross 8 image of digits. We have 10 classes, which is 0 to 9, and the sample per class is less than 180 samples. Sample total 1797, and this is how we need to import the load digits. So sklearn datasets import load digits. So total we have 1797, 64. Similarly, if you see the image, so the training, it's saying 0, this is how it's look like. It's a handwritten images. So 1 it look like this, 2 look like this, and 3, and so on. Here also few images, the sample images. Yeah, this is how the image look like. So it's 8 cross 8. We can see that the image, the entire image, it's a handwritten digits. Yeah, we have some more samples here. Uh, yeah, let's go back to our steps again. Let's start from step 1. The step 1, load required libraries. These are all the libraries we need as part of this POC. We need the datasets. The datasets we are taking it from the sklearn datasets. It's a load digits. It's a free datasets, free to use. And we need pandas, numpy, and the algorithm we are using random forest classifier. So we are taking it from sklearn ensemble random forest classifier. Let me run quickly this one. Okay. So we are in step 2 right now. So the step 2, import the dataset. So we are loading the load digits. So the digits we have data, target, and images. So in X we have the digit star data, Y we have digit star target variables. Let me quickly run this and show what type of data it is. It's already numpy.array. So the data is in a numerical format. It's not a real image. It's already converted into the numerical format. So it's ready to use by our algorithms. So this step, it's showing the shape of the data. So if you see here the digits.data.shape, we are getting 1097, 64, because 8 cross 8, it's a 64 dimension, and we have the samples of 1797 images. And the target, we have the target variable, and the shape of the image, it's showing 8 cross 8. Now in this step, I'm putting together all our data as well as the target variable, so that we know like how this look like. Let me show how this data is. The data is already in the numerical format. If you see here 0 to 63, and we have a target. Target also, it's part of the data from right now. So now for the first record, the image is 0, and the second record the image is 1, 2, and so on. So this image is already in NumPy array. It's already converted into array. It's in numerical format so that our algorithm can able to use it. In case if it's not in the numerical format, we may need to convert that into the numerical format before feeding into the model. That's the one of the extra step we may need to consider if the images are not in the numerical format. We are in step 3 right now. Here we are going to display all images one by one. So we have the digits.images already. I'm just showing that the first digits. So the first digits look like this, first image. Digits.images of 1, that's a number 1 digit, that's look like this. And similarly for the digits.2, like this. We have a 3, handwritten image 3, digits of 4, similarly for digits of 5, and here we are displaying all the images together. So 5 to 10, 5 to 10, all images together here, image 5 to image 9. So we just took some samples and displayed it here, the first images 0 to 9. That's how these images look like. In this step, we are going to see how many images we have for every classes. So we know already that the class we have 0 to 9, and every classes how many samples we have. That is this step. So this step executed right now. If you see here 0, we have a count of 175. So we have 175 images which contain 0, that is the samples. Similarly for digit 1 we have 178. Similarly for digit 2 we have around 175. So most of all the samples are equal. We have less than 180 samples in every classes. So that's what it's displaying here, 0, 1, 2, 3, 2 up to 9. Currently we are in the step 4. So this is building a random forest classifier. Before building a model, let me quickly explain what is random forest algorithm is. I have some 5 points. Let's start one by one. Random forest is a supervised machine learning algorithm that is widely used in classification and regression related problems. Point number 2. Random forest builds multiple decision trees and merge them together to get a more accurate predictions. So random forest is not a single tree, it's a combination of multiple decision trees. Random forest equal to multiple decision trees, tree 1 plus tree 2, tree 3 up to tree n, which means the output of the random forest not from a single tree, it's a combined output from all the trees. It reduces the overfitting of the datasets. Why? Because the output is not from a single tree, it's a combined output from multiple trees. Also, it handles missing values. Point number 5, it's a great algorithm to build the model fast, simple and efficiently. Without adding any hyperparameters tuning, we could get very good score from this model. Now let's get back to our model building steps. Here just extracting the train test split. So here I am taking 75 and 25. 75% of our data for training purpose and 25% of our data for the testing purpose. So that's a split happening here. And I'm just displaying the shape of it. So right now if you see here, this is our train 1347 and 450 our test. So the 450 records we are going to keep as testing purpose, and 1347 records we are going to use as a training purpose. That is what this step is telling about. So in this step we are training our model, so the random forest classifier, and we are fitting the training data. Now our model is ready. Our model is built and it's available for us. This is our model. So we are trying to get the score of it, rfc.score of x test and y test. See here we are getting 97% of the score, which is good, because this data sets we have very limited number of samples. We don't have like much records. We have only less than 2000 records here, but for these records this is a very good score. So this score is telling about, so the 97% is correct, which means out of 100 sample, out of 100 predictions, our model can able to predict 97 values correctly. So in this step, we are going to see the total number of classes. We already know that we have the classes, 10 classes, which is 0 to 9. But we are going to see that as part of this. RFC.classes will give us what are all the classes we have. RFC is nothing but the random forest classifier variable. So here if you see the RFC equal to random forest classifier of random state. Now our model is ready, and it's already tuned, and we are going to make a prediction out of it. So in step 5 we are going to get a prediction, and to get the prediction we are going to use the test data. I'm just taking that the initial 10 value, like initial 10 values to get the prediction. So if we see here x test of 0 to 10, so our model going to predict and tell us what kind of image digits those are. We got a predicted digits. So now if you see here, we have the prediction. This is how the images are. It is saying that in your test data, the first 10 digits, so those are all 2, 8, again 2, 6, 6, 7, 1, 9, 8, 5. Let's going to validate this one, whether the prediction is correct or not. That is the next step, we are going to validate it. But right now, this is how we got a prediction from the model. So this step we are going to take the actual value and compare whatever we got the output from the model as well as what we have right now. That is what the comparison here. So here we are taking the y test of 0 to 10, so the first 10 digits. So if you see here again the same thing we are getting, which means our model predicted all the values correctly. So the actual values are 28266 71985, and our model prediction also the same. So here if you see the observations, so observed digits, these are all the observed digits, and the random forest model predicted digits, so both are same, and we are not seeing any mismatch between the model prediction as well as the observed values. We are in summary right now. So far we have learned how to load digits dataset from sklearn. Also we displayed a couple of sample images. Similarly, we did a train and test split on our data, and we did a model building and model prediction. Also we compared the predicted output as well as the original output from our dataset. Thank you so much for watching. All these steps are reproducible. You can use Google Colab and execute all these steps. You don't need to install any software or any configuration required. Also, I have given this notebook link in the description. You can utilize this. Please let me know if you can able to reproduce and then successfully execute random forest model and get familiarized with this.